Okay, 25. So on 25, you have this nice 1 plus tangent theta over 1 minus tangent theta. And you're trying to prove that it equals cotangent theta plus 1 over cotangent theta minus 1. Did you work from left to right or right to left? Let's use hands today. Hands. Left to right or right to left? Yeah? Left to right. What did you do first? Someone raise their hand and tell me what you did first. So you went from left to right. What did you do first? Yeah. So 1 plus sine theta over cosine theta all over 1 minus sine theta over cosine theta. So at this point, what are you going to do? Multiply what? Multiply cosine. Need a complete sentence. Multiply by. Cosine theta is not 1. You can't multiply by just cosine. So let's use the whole complete sentence. That makes sense. Nope, you said it right. You're just not getting it. Multiply by. Nope, there's no both sides. So multiply by cosine theta over cosine theta. There's the complete sentence. Cosine theta over cosine theta, and you end up with cosine theta plus sine theta over cosine theta minus sine theta. Now what do you do? Now what do you do? Yeah, you can multiply 1 over sine theta over what? 1 over sine theta. Exactly. So what's cosine over sine? So it's cotangent theta plus 1 over cotangent theta minus 1. Can you combine these two steps if you really wanted to? Multiply by cosine over sine, which is cotangent. Could you just multiply by cotangent over cotangent? Sure. You could. Breaking it apart in 2 steps is totally acceptable, though. Here we go. Next, 33, I think it was. Was it 33? Sine theta over sine theta minus cosine theta. So someone who hasn't spoken up yet, can someone tell me what's a great thing to do to this first? Or which should I go from left to right or right to left? Someone raise their hand and I'll call on them. What do you think? Left to right or right to left? Goss. You can go left to right. You can. Who did it from right to left? I'm just going to overrule you for this one. Let's go right to left and see. You can tell us if it's faster, okay? You can tell if it's faster. So if we start on this side, what should I do, Pang? Yeah, so you end up with 1 over 1 minus cosine theta over sine theta. Exactly. And what am I going to multiply this thing by? Yeah, if you do sine theta over, what happens? You get sine theta over sine theta minus cosine theta. Now, is that quick? Yeah, that's about as quick as it gets. Going from left to right is possible. Is it a little more ugly? I'd imagine it is. What did you multiply by? Oh, you did. What did you do for the 2 fractions? That's not correct. Yeah, a over a minus b does not equal a over a plus a over negative b. You can't, be careful with your fractions. I think that's what you said you did. Can't do that. Careful. Careful. Because then you should have 2a. You need 2 sine on top. Yes, Brown.
Like when you have like the left side was in terms of sine and cosine, the right side was in terms of cotangent. Should like whenever you see a problem like that, should you always work from the side that's not in terms of? That's a good observation. I really don't want to make any absolute statements. Well, no, but is it sometimes
I think that's a good idea. I think that's a good idea.
Yeah.
I think generally because you're generally aiming for simpler trig functions, and I've used sine and cosine since everything's written in terms of them, the simplest ones. I think that's a good tactic to take. I like that. If you see things in terms of cotangent, secant, cosecant, and it's on the right hand side, yeah, start over there.
Yeah.
In this case, boom, done. Okay, so you finished those 2, and how are you feeling after you finished those 2? Pretty good? Decent? So now we start with this. Sine theta. So, discounting the people that just cross-multiplied. Please don't do that, please. Oh wait, that's not it. Sine theta plus 1. All over cosine theta, yeah. Which side are we going to start with? Unfortunately, which one do we really have to start with? You really got to start with the left. There's nothing really you can do to the right. You have to create too much. It's not going to work. You have to create too much out of thin air. It is possible to create things out of thin air in math, like adding the same thing to both sides. Is it generally an easy thing to do? No. So we're going to start on the left and figure out what we should multiply by. So we're starting here. We're going to work from left to right. And the key to all of this is, and I think I said this yesterday, you have to figure out what you need to multiply by. But it is not immediately apparent what you should multiply by. And even, guys, even as when you find the right thing to multiply by, it takes a while to see that it works. On other ones, when you multiply by the right thing, what happens? It collapses really quickly. On this one, is it going to collapse fast? It's not. So what did people try multiplying by? What's one thing someone tried multiplying by? Okay, look at your work. I know all of you tried something. What did you try multiplying by? No one multiplied by anything? Yeah? Oh, so you did so you did sine theta what? Yep. You tried that? So we tried this. Sine theta plus cosine theta plus 1. Did this work for you? What? You think so? You don't think so. Yeah. The problem with this is you get to a place where you're not sure if you did something wrong or it is actually wrong, right? My guess is it got really nasty really quick. I'm going to rearrange this for you a little bit. I'm going to edit this just a tiny bit to see if you can see if this helps you out a little bit. That's a good guess. That's actually really close. That's very close. I'm going to do something really key here. Is it okay if I put parentheses right there? Does that change anything? What? Does that change anything about the fraction? If I put parentheses here, does that change something about the fraction? Yeah, it does. If I do that, what do I have to change this to? Minus. So now, have I changed anything? No. So you should see two terms. A term on the top and a term on the bottom. Well, two terms on the top. So you see two terms on the top and you see two terms on the bottom. Given that, we are going to multiply by something that looks like this. Sine theta blank cosine theta blank 1, and then the same thing here. There are 4 blanks there. Two of them have to be the same. So the yellow ones have to be the same, and the blue blanks have to be the same. How many different what can go in there, plus or minus? So how many different possibilities are there? Minus, minus, and minus, plus. You're building conjugates of sorts. The issue is, if you choose the wrong one, actually, I don't know, maybe there are multiple ones that work. I know one of them does work. I'll tell you that. One of these 4 does work. I don't know if the other 3 work or not because I haven't tested them all. The problem is testing, does it take a little while? Yeah, it does take a little while. Is it kind of nasty? A little bit. A little bit. Can you definitely do it? Absolutely. Which one do you want to try first? Want to try minus, minus? Let's try minus, minus and just look at the top or the bottom. Do you want to look at the top or the bottom? Top. Sine theta minus cosine theta minus 1 times sine theta minus cosine theta minus 1, like this. You want to try that? So this is just the numerator. We're looking at option 1, just the numerator. If this thing blows up, is that a bad sign? It's a pretty bad sign if it totally blows up. So if we multiply this out, what might be a good thing to do before we multiply it out? I'll just tell you. I want you to do this. Times cosine theta. Just clean it up a little bit. Now multiply it out. Everything in the left has to be multiplied by everything on the right. So how many terms are we going to end up with in our new one? 9. They might simplify, but there's going to be 9 of them. So you end up with sine squared theta minus sine theta cosine theta plus minus sine theta cosine theta. I'm just putting it in the same order. Plus cosine squared theta minus what? Cosine theta. And what's the last one going to be? Plus theta minus cosine theta plus. Do we have any similar terms here? Do we have any similar terms? Okay, we have sine squared. Are there any other sine squareds? Are there any other sine squareds? No. Now we have negative sine cosine and negative sine cosine. So how many do we have? Negative 2 sine theta cosine theta. What else do we have here? Sine thetas and plus what? So we got rid of those. What about the cosine squared? Plus what? That one's gone. Minus 2 cosine theta plus 1. Are we good with that so far? Have we considered everything? Yeah, we have. What is sine squared and cosine squared? That's 1. So what do we have? We have 1 and 1. So now what do we have? 2 minus 2 sine theta cosine theta plus 2 sine theta minus what? 2 cosine theta. What can we factor out of everything? 2. 1 minus sine theta cosine theta plus sine theta minus cosine theta. Yeah. How many? We still. It's simplifying. Are we getting a good vibe on this? Kinda, but not really, right? Go to lunch. We'll talk about this when you get back. Interesting about this is you can actually factor that. What's above the yellow? You can actually factor it. The 2 stays the same. You have a 1 there. You're gonna multiply. It's gonna be 2 things. So what are 2 of the terms gonna have to be? Sine and cosine. That's right. And what are the other 2 terms gonna have to be? 1. Yeah. It's gonna be 1 sine theta and cosine theta. Now figuring out what the signs are, a little tricky, but is this? Look at these 2. Which one's positive? The sine is positive. So it's going to be 1 plus sine. Let's test that out. 1 times 1 is 1 minus cosine theta plus sine theta minus sine theta cosine theta. Is that check? It does work. So we just did the numerator, and is that a good way to? Is this nice? Yeah, it's not exactly what we want, but we haven't done the denominator. When we do the denominator, what could theoretically happen? Something could cancel, exactly. It might simplify further. So we just did the numerator, so let's do the denominator. It's very similar. It's very similar, except just one sign is different, right? So it's that right there. And what are we multiplying it by? We have to be very careful about this. Sine theta minus cosine theta minus 1. We chose minus and minus, right? What was the first thing we did? So this right here was, let's just write this up. This was the numerator. So now we're doing the denominator. Let's see if it comes out. What did we clean up first when we did this one? The parentheses, yeah. So we did sine theta plus cosine theta minus 1, sine theta minus cosine theta plus 1. Again, how many terms are we going to end up with when we multiply this out? 9 of them. So we end up with sine squared theta minus sine theta cosine theta plus sine theta cosine theta. Stop talking, please. Plus cosine theta. That's 6 terms, right? And what's the last one going to be? Minus sine theta plus cosine theta minus 1. Now, are there any things that cancel out in there? What do we got here? Well, the sine, we know there's the... We're close here. Look. Is that really nice? That's great that gets out of there, right? Look. The sine theta and the sine theta, right? So what are we left with? Sine squared theta minus Ooh. We have something there, actually. There is something there that's really nice. First of all, what's something at the beginning that looks like it potentially could be nice but actually isn't? Yeah, if this is, it's sine squared minus cosine squared, is that anything? No, it's not. But look what we do have. We do have something here. We have something close. We have a minus 1 and minus cosine, right? It's almost what we want, right? I mean, keep in mind, we know that sine squared plus cosine squared is equal to, so cosine squared is 1 minus sine squared. And we know that sine squared, well, 1 minus cosine. The problem is that's negative, right? Oh, but look at this. What's this? We have this and sine squared, right? So let's just rearrange these terms. Let's rearrange it and see if it makes more sense now. We have sine squared theta minus 1 minus cosine squared theta plus 2 cosine theta. What is sine squared minus 1? Yeah, this is negative cosine squared theta minus cosine squared theta plus 2 cosine theta. What is, how many are there? Ah, is this a good sign? Negative 2 cosine squared theta plus, what can we factor out of both of those? Let's factor out negative 2 cosine theta. Is that okay? I like factoring out the negative. So we get negative 2 cosine theta times what? Nope. So what is this? Is this a pretty good simplified, what is this? Denominator. So let's put it all together. So now we have negative 2 cosine theta times cosine theta minus 1. And what do we have on top? I got to remember what it was. Oh, that didn't do it. Okay, what is it? 1 plus and 1 minus cosine? What is it? 1 plus what? 1 minus what? It's like that, right? It's really close. What's one thing we can almost cancel? The 1 and cosine, right? But they're the opposite. So how do you take this negative and multiply it in? And you end up with 1 plus sine theta, 1 minus cosine theta, all over 2 cosine theta times 1 minus cosine theta. And what happens? What do you end up with? 1 plus sine theta over 2 cosine theta. Oh, there was a 2 up there too, right? Yay! Hallelujah. Is that what we wanted? Did it work? Yeah, it is so long. And here's the thing. We now just proved a second combination worked. There were 4 of them, right? Which one did we choose that worked? Minus and minus, right? When we did this out in the first class, we did minus. I think we did minus first, and we couldn't get it to work. We got stuck in some algebra, so we tried another one. In the other class, I think we tried. We can just check this here. In B block, we ended up with. Yeah, see, they really don't like trig right there. The one that worked for us was right there, minus plus. We got minus plus to work. The first one we tried was indeed minus minus, and we got stuck. So I wonder if all 4 of them work now. So we got minus plus to work. We got the 4th one to work. So that's a long one. It's nasty. What's particularly heinous about it is it's not very clean the entire way. And what was really what was the magical step that we did that made this all worthwhile? The factoring thing. Yeah, this right here, that's pretty nasty. That's pretty nasty. Is that something you've traditionally had to factor? No, when you deal with trig, you usually do a trig identity substitution. Things cancel, things simplify, they cancel, they simplify, and it's nice. In this case, it's not the best, right? Okay, put everything away except a pencil and a calculator.